Okay, this is lecture 14, and lecture 14 is about geometric distribution. We did binomial distribution in lecture 13, and now we are in geometric distribution and Poisson distribution. Let's start with the geometric distribution. This is another type of distribution. Just like binomial distribution, we have these other two types of distribution. Binomial distribution has some properties. This has some different properties. These look similar, but they are of different types, and they have different methods, different formula, and different conditions to satisfy. So let's see, what does the geometric distribution say. A geometric distribution is another discrete probability distribution of a random variable x which satisfies the following condition. The trial has two outcomes, success or failure. The trial is repeated until a success occurs. Each repeated trial is independent to the previous trials. The probability of success is same for each trial. The random variable represents the number of trials in which the first success occur. In binomial distribution, we had the total number of trials. Given certain total number of trials, we find how many success we get within those number of trials. That was in binomial distribution. Right? You see, if you remember, I gave you an example of basketball court, and a player throw a ball to the basketball net. Right? In binomial distribution, we said let's give a number of trials, certain number of trials, 10 trials, and we count how many success the person get within 10 trials. That was binomial distribution. A geometric distribution, it doesn't have any number of trials. Like, you can throw as many times you want, but you have to stop at the first success. Okay, so you throw the ball, and if you get success, you stop. If you don't get success, you keep throwing, and you can try many times. You can try as many times you want, but you have to stop at the first success. If you get the first success in fifth trial, you stop at fifth trial. So we only count the first success. We don't have the total number of success. We only have the first success. So we only have the x value. We don't have the n value. Okay, so that's how it says. See, it says that the trial is repeated until a success occur. So you repeat the trial until you get the success. Okay, and the experiment has two outcomes, success or failure, and we stop after the first success occur. And each trial is independent to the previous trial. Like, you throw the first time, you get unsuccess, it has no relation with the second trial, because the second trial you can get success, or you can get unsuccess again. It doesn't have any relation to the previous trial. The probability of success is same for each trial, because the same person is doing experiment, so the probability for each trial is same. The random variable represents the number of trials in which the first success occur. Okay, so random variable is x. The x means the number of trials in which the first success occur. And here the notations are: p is the probability of success in one trial. So if the player is a good player, the probability of success is high. If the player is not good player, the probability of success is low. So that probability of each trial is denoted by p. Okay, and q is the probability of failure in one trial. P and Q are the opposite of each other. If P is 90%, Q has to be 10%. And X is the random variable which equals the number of trials in which the first success occur. So the first success occur, it says, for example, if the first success occur in third trial, then X equals to 3. Okay, if the first success occur in the first trial, then X equals to 1. X equals to 1. So like that. So that's how we find the X. So we count the number of success. We use this formula to find probability of first success occur in X trial. Like there is a player throwing basketball to the court, to the net, and what is the probability that the person gets success, like he throws the ball successfully in fourth trial. I mean, in fourth trial he gets success. What is the probability? So that types of question is in a geometric distribution. Okay, so we use P times Q to the X minus 1. P is the probability of success, Q is the probability of failure. So this to the X minus 1. So we use this formula. Okay, question 1 is a basketball player makes a free throw shot about 75% of the time. Find the probability that the first free throw shot he makes occur on the third attempt. So 75% of time the player makes a free throw shot about 75% of the time. So this is the probability of each, means probability of success in one trial. So that is P. So we have P equals to 75%, which is 0.75, and find the probability that the first free throw shot he make occur in the third attempt. So X equals to 3. We don't have N for geometric distribution. We have the P and X. And if P is 75%, then Q equals to 25%. So 0.25. So you can use this formula. Q equals to 1 minus P. You can use this formula because P and Q has to make a total of 1. So always we do that. Q equals to 1 minus P. So this is equals to 1 minus 0.75 and this is 0.25. So this is Q. Okay, just Q, not the probability answer, just Q is 0.25. Okay, so we do probability of first success on third attempt, right? So first success in third attempt. First success in third attempt is we write it probability of 3 like this. Okay, X equals to 3. You can write P and the parenthesis X equals to 3, or you can simply write P3, and that is equals to, we use this formula P. This is the probability for, like, this is lowercase p, and this probability P with the uppercase P is probability, this uppercase P, probability of the person getting success in the third trial, equals to P times Q to the X minus 1. And here P is 0.75 times Q is 0.25 to the X minus 1. X equals to 3, so X minus 1 is 2. Right, so this is equals to, now you do that calculation. We use calculator for that. Let's see, 0.75 times 0.25 to the 2 equals to 0.04685. You can round it to 4 decimal place, Don't round it to too many, like don't round it to 2 or 1 decimal. Just keep 3 4 decimal. Okay, so at least 4 decimal. I suggest at least 4 decimal number. So this is the probability. So here we need to find out the p value, and then q and x values. We don't have n, so we just have p, q, and x. Okay, so let's see the next question here now is I think similar type. A basketball player makes a free throw shot about 75% of time. Find the probability that the first free throw shot he makes on third or fourth attempt. So here we need probability of third or fourth. Okay, so P 3 or 4. In probability, if we have an or, that means we add probabilities. Okay, so this is equals to probability with 3, x equals to 3, plus probability with x equals to 4. Probability of 3 and probability of 4. Okay, so this means probability with x equals to 3 plus probability x equals to 4. Now for this we use this is here you have x equals to 3, and here you have x equals to 4, right? So x equals to 3 and x equals to 4, and 75% is p. So here p, the lowercase p is 0.75, and here the lowercase p is 0.75, and so q is 0.25. Q is 0.25. Use this formula this formula again for each of these, and we add them. Okay, and we get the answer. So here we use p times q to the x minus 1, right? So 0.75 times 0.25 to the 2, because x equals to 3, so 3 minus 1 is 2, and plus, because this is plus, and here is 0.75 p times q, 0.25 to the x minus 1. So here x equals to 4, so 4 minus 1 is 3, and this is equals to this simplification is here, actually we did in here, it's the same thing. So that is 0. So what we get here is 0.046875. So this answer for this part only, and plus, and let's see what we get for that part. 0.75 times 0.25 to the 3. Okay, that equals to 0.01171875. Let's write all of them, and then this is equals to now you add these. Okay, so plus this answer plus that answer, 0.046875. So I get 0.058. Let's round it to 6. This is the answer for third or fourth trial. So probability of getting success in third or fourth trial is 0.0586. Okay, so this question we could use calculator to find the direct answer. It's like we did in binomial distribution. We use calculator to find the answer, the direct answer without any calculations of these. We could do that for this question too. If we do that, if we use calculator to find the direct answer for any geometric distribution, we follow the same process that we did in binomial distribution. So let's see, let's do the next question by using calculator. Okay, so here is find the indicated probability using a geometric distribution. So it is a geometric distribution, P5 when P equals to 0.65. So given P and X equals to 5. If P equals to 0.65 and X equals to 5, because P5 is X equals to 5. See here, P3 is X equals to 3. P4 is X equals to 4, right? So here we did P3 and that was X equals to 3. And so here it says P5. So this is X equals to 5 and P equals to 0.65. So for this question, we have X equals to 5 and P equals to 0.65. Okay, and this is geometric distribution. This is a geometric distribution, right? So let's follow these steps. See, let's follow these steps. We start with the distribution, so second variance. So we use these steps. So it's steps. So we start with second. Okay, so let's see. Second, then variance. This is the distribution. Actually, second variance is a distribution. And then what you do, say, let's say, so you do second and variance. Okay, so when you do second variance, you'll get these things. Okay, so here you get these. So you get the list of distributions, normal distributions, normal PDF, CDF, and inverse normal, and so on. So you scroll down, you go down to geometric PDF. Okay, so here is geometric PDF. You see that? So here is geometric PDF, geometric CDF, geometric PDF. We choose PDF. Okay, if we choose PDF, PDF is actually for individual number. Like here, X equals to 5 is PDF. If we need less than 5, then we choose CDF. But we do PDF for one number, 5. If there is a 6 or 7, or for each individual number, we do PDF. Okay, so we choose geometric PDF. Geometric PDF, and then you choose that. So enter, right? So you get this screen. You get P and X value and paste, right? So you get, let's see, you get let me, okay, so you will get this P and X value and paste. Okay, so you put P value. P is 0.65, so you write 0.65 and X value is 5, and then you do paste. Then we do paste, and then we enter. Okay, so let's see. So here I write P equals to 0.65, right? So P equals to 0.65 and X value is 5. Okay, and then you'd go down, paste, enter, and enter. So you get 0 point, so you get the answer, and the answer is 0.00975. Okay, so that is the answer. So we use this process, we use these steps to find probability, geometric probability, given p-value and the x value. So we could use this process calculator to find this question and this question. Okay, so let's say, for example, let's do this question and check if we get this answer, right? So let's see, we do let's see, clear it. So what we do is we do second variance, right, and go down to geometric PDF. Okay, so there, geometric PDF, and we'll put p equals to 0.75, x value is 3, and paste. We don't even need to find the q value because it does it by itself. Calculator does it by itself. If we put a p value, it calculates q value somehow. So it only needs the p value. It doesn't need q value. P value and x value only. So you have those values, you can find out the answer. So see what answer we get there is 0.046875, right? So we get the same answer here. See, 0.046875. Okay, so this is the calculator process, calculator method to do the geometric probability distribution questions. Okay, so the next page is about the Poisson distribution. Okay, so it is Poisson distribution. It looks like Poisson distribution, but we don't say Poisson, we say Poisson distribution. This is a discrete probability distribution, okay, of the random variable which satisfies the following conditions. Now this is another type of distribution which satisfies these conditions. The experiment consists of counting the number of times x an event occur in a given interval. The interval can be a fixed time interval, area, or fixed volume. So now we have a certain interval of time. We say that within 1 month, right? You know, if something happens within 1 month, it is not like you try 5 times, 6 times, or 7 times. You try 1 month and then see what happens. You know, how many times you get something or any condition like that. So it has a time frame, it has certain area interval, it has certain volume interval. So that types of things come in this Poisson distribution. The probability of the event occurring is same for each interval. The number of occurrence in one interval is independent of the number of occurrence in the other interval. And then the probability of exactly x event occurring in an interval is given by the following formula. So we have a special formula to calculate the Poisson distribution. Okay, so the only difference, what is the difference in this and the one we did with binomial distribution and geometric distribution? In binomial and geometric, we had number of trials. It gives number of trials. It gives a successful trial and those n values and x values. But here is it gives certain interval time, and in intervals something happen in this many times, like it has time interval or some other type of, like, you know, other type of interval. It says it looks something different than those number of trials type of question. Okay, so let's see here. Let's see, this question is right here, is the mean of the mean number of accident. You see, so this is one example that I'm trying to show why this question is different from the previous other questions. The mean number of accident per month at a certain intersection is 3. What is the probability that in any given month, 4 accidents will occur at this intersection. You see, so that's how this type of question is. It's a different type of question, right? So not the number of trials, given certain number of trials and counting the successful trials like that. It doesn't have like success, failure, or anything like that. Binomial distribution and geometric distribution has success and failures. Those have p, q values. But here we have the mean number of accident, mean number of happening in a certain interval is this, and what is the probability of something happening like this many number of times, like that. So this is example of accident occurring, accident happening in one intersection, in certain intersection. Okay, so we use this formula, and this formula is the probability of something happening in a given interval. So x counts the number of times the event occur. Mu is the mean, and see here, mu is the mean number of occurrence in a given interval, right? And e is nearly equals to 2.71828. This is a standard number. It is used in many mathematical questions, many mathematical problems. We use e. It is a special value. Okay, so it is a special value, 2.71828. It is a non-ending decimal in there, but we round it to 2.71828. Okay, this is irrational number. E is a irrational number which has many applications, and to use e we round it to like a 4 or 5 decimal number, and therefore we use a nearly equal sign, not equal sign like this. We use nearly equal sign, and this is x factorial, right? So we did factorial in binomial distribution, so that is this factorial. Okay, let's solve this question. Mu equals to 5, x equals to 4, and Poisson distribution. How to find the probability? So here probability of x equals to, here x equals to 4, right? So we write probability of 4 because x equals to 4. You can write px or you can write p4, x equals to 4. These are the same thing. So mu to the x, okay, so mu is 5. Right? So 5 to the x equals to 4, 5 to the 4, 5 to the 4 times e to the negative mu. Mu is 5, so e to the negative 5 divide by x factorial. X factorial is 4 factorial, right? So 4 factorial, and this equals to 5 to the 4 is 5 times 5 times 5 times 5. We can do by calculator, or it is 625. 5 times 5 is 25, and 25 times 25, 625 times e to the negative 5. So you could put e equals to 2.71828 to the negative 5, and we can do this by calculator. Okay, so we use calculator. So if you check in carefully in calculator, you can see e in here. You see here e to the x, you see that? So we can use that, or you can type those numbers. Okay, I suggest you use e, the same e, because if you do this, then there is a chance to get accurate answer. Okay, so we do e to the, you see that e to the negative 5. So use this negative sign. Okay, so this negative sign, not this negative sign. This may give error. If you use this one, you may get error. So we use this negative sign. So use this negative. So you get e to the negative 5. E to the negative 5, and then multiply. So e to the negative 5 multiply 5 to the 4. You can do that, 5 to the 4. So let's see, 5 to the 4, okay, equals to 4.5 Okay, let's cancel this number. So this top part is 4.2121 or 211,216,874. Now divide that by 4 factorial. What is 4 factorial? Is 4 times 3 times 2 times 1. 4 times 3 is 12 times 2 is 24. Okay, so 4 factorial is 24, because 4 factorial is 4 times 3 times 2 times 1, and this is 24. So that is 4 factorial, and this is equals to, now you divide by 24, right? So this is equals to 0.175, let's round it to 5, 0.1755. That is the probability of probability when x equals to 4, mu equals to 5 for Poisson distribution case. Okay, so the last question here is the mean number of accident per month at a certain intersection is 3. Mean number of accident is, mean is denoted by mu equals to 3. And what is the probability that in any given month 4 accident will occur? We'll find x equals to 4. So the same as this, x equals to 4, mu equals to 5, and here we have mu equals to 3, right? So we use the same formula. So you can do probability of 4 equals to mu to the x times e to the negative mu divided by x factorial. We can do this. So mu to the x is 3 to the x equals to 4, 3 to the 4 times e to the negative mu. Mu is 3 divide x factorial, 4 factorial, and then we simplify this. Let's say 3 to the 4, right? So 3 to the 4 multiply e to the e is second, and ln e to the negative, so we use this negative again, so negative, right? So negative 3 equals to 4.03275 divided by 4 factorial, which is 24, and divided by 24 is 0.1680. Okay, we can use calculator to find the Poisson distribution. We'll do the same process. We start with second and variance, so that gives us the list of distribution, and this is using calculator TI-84 plus calculator. Second variance, and then you go down to Poisson PDF. Okay, Poisson PDF. Let's see what we get if we do this. So let's clear it. Let's see. So we do second and variance, and we'll scroll down, go down to Poisson PDF. Okay, see, there is Poisson PDF. Okay, so we use that. Then you get this thing, lambda is mu. Okay, we use mu for mean, but sometimes in calculator we have lambda. So lambda is same as mu, lambda and x values, and paste. Okay, so we get this screen. So we get lambda and x value and paste. So lambda is the mean, mu value. So mu is 3. So put 3, Okay, so we use 3, and x value is 4, and then you do paste, and then you do enter. Okay, and then there you will get the answer. So let's see, we put lambda equals to 3, go down to x value, x equals to 4, and go down to paste and enter, and again enter. So you get 0.1680, right? So this is the answer. Okay, so that's how we use calculator, and we use the formula to find Poisson distribution. So this lecture was about Poisson distribution and geometric distribution. Now we are done with geometric distribution and Poisson distribution. For this lecture, you don't have any homework, but please make sure that you understand how to do these questions, how to use geometric distribution, how to use the formula, and how to use the calculator to solve geometric distribution. Okay, so we use this process, these steps to do calculator using calculator, and make sure that you understand the Poisson distribution, and what is the difference in geometric, binomial, and Poisson distribution. So you should know that part, and also know this formula. This formula is for Poisson distribution. We use this formula to calculate Poisson distribution. Or if you want to use calculator TI-84 plus, use these steps to find Poisson distribution questions. Okay. You have no homework for this lecture. Okay, but you will have a test coming soon. You will have a test coming soon, and let me check. Maybe I may give you a test within few days. Okay, so keep checking your Blackboard. There I put the information if I'm giving you the test. Before I give you the test, I'll put the test review questions for the third test, and you need to practice those questions. Okay, you need to practice those questions, and then I'll give you information. I'll put some information about the test in the next time. Okay, all right.